Hello viewers, now let's solve this thermal physics question. Now we have the latent heat of vaporization of a liquid is 2300 kilojoules per kilogram, and it has a molar mass of 0.018 kilogram per mole. Now what is the energy required, okay, to change 30 moles of the liquid into gas? That is vaporization. That is, the when we talk about latent heat of vaporization, latent heat of vaporization measures the amount of heat energy required to convert 1 unit mass of the liquid into what? Into vapor. Okay, that is when a body changes from liquid state into vapor state. That's when we talk about vaporization. So in this case, the amount of heat required, or the amount of heat energy required to convert 1 unit mass of the liquid into gas at a steady temperature or without a change in temperature is what we call latent heat. So here we have the latent heat of vaporization to be 2300 kilojoules per kilogram. So which means this implies that it will take 2300 kilojoules of heat energy, to vaporize 1 kilogram mass of the liquid. All right, so that's what it means. So now let's have our solution. So here we are giving latent heat. We are giving the latent heat of vaporization. Okay, latent heat of vaporization, and that is given to be 2300 kilojoules per kilogram. All right, then also we are giving the molar mass of the liquid. Now we are giving the molar mass of liquid. Now the molar mass of the liquid, that is capital letter M, molar mass of the liquid is given to be 0.018 kilogram per mole. Molar mass is the amount of substance expressed in kilogram per mole or gram per mole, because here the unit selected is the standard unit of mass, because we know that the standard unit of mass is the kilogram. So that's why we have this as 0.018 kilogram per mole. Now, what is the energy required to change 30 moles of the liquid to gas? That's what we are required to find out. So the first thing here is to use one of the formulas in mole concept. From mole concept, we know that from mole concept, we know that number of moles, or we can say mole of substance, okay? Now, number of mole is equals to, we have it as reacting mass, okay? Reacting mass, which is represented with small n, small letter n, lowercase letter, then over what? Molar mass, 2.4 mole per dm³, okay? That's in chemistry, or 22,400 cubic centimeter per mole. All right. Now, in this case, so now, like I said, we're using mole concept. Now, we're giving 30 moles of the liquid. So, which means the number of moles is what? 30 moles. Okay. Now, we're giving the molar mass of the liquid. Okay. The molar mass of the liquid is given to be 0.018, okay, kilogram per mole. All right. So, but we want to find out what is the mass of the liquid. So the mass of the liquid is what we are looking for in this case. That is, we need to first calculate the mass of the liquid. So it is only when we know the mass of the liquid that we can be able to calculate the energy required to change 30 moles of the liquid to gas. All right. So now in this case, so we know that the reacting mass, which is ml, we have number of mole, that's number of mole of the what? Of the liquid, is equals to the reacting mass of the liquid all over the what? The molar mass of the liquid. So in this case, we then have the reacting mass of the liquid, which is the mass of the liquid, okay, will be equals to number of moles of the liquid multiplied by the molar mass of the what? Liquid. Remember, we have here that the molar mass is 0.018 kilogram per mole. All right, so in this case, so the mass of the liquid will then be 30 moles, that is 30 multiplied by the molar mass, which is 0.018. All right, so the unit of this will be the what? Kilogram, because like I said, the standard unit of mass is the what? Is the kilogram. Okay, so 0.018 when multiplied by 30, okay, that will be 0.54. So the mass of the liquid will be equals to 0.54 kilogram. So that is the mass of the liquid. Now, to be able to calculate the energy required to change 30 moles of the liquid to gas, that's why we have latent heat of vaporization, which is the amount of heat energy required, to convert a unit mass of the liquid into what? Into vapor or gas without any change in what? Temperature. When we talk about latent heat, that is the hidden heat which transform a substance, okay, from one state to what? Another without any change or any rise or any increase in what? In temperature. That means at a constant temperature. All right. So now we have the latent heat of vaporization. So the heat energy required. So we are looking for the energy required. So the energy required, which is Q, will be equals to the mass of the liquid, okay, multiplied by latent heat of vaporization. Oh, that's it. Latent heat of vaporization, not latent heat of fusion. Okay, when it is LF, that will be latent heat of fusion. Okay, but in this case, it is L any change or any rise or any increase in what? In temperature. That means at a constant temperature. All right, so now we have the latent heat of vaporization. So the heat energy required, so we are looking for the energy required. So the energy required, which is Q, will be equals to the mass of the liquid, okay, multiplied by latent heat of vaporization. Oh, that's it. Latent heat of vaporization, not latent heat of fusion. Okay, when it is LF, that will be latent heat of fusion. Okay, but in this case, it is LV, that is latent heat of vaporization. It will be latent heat of fusion when we talk about the amount of heat energy required to convert a unit mass of a substance in its solid state into liquid without a change in temperature. So that's in the case of latent heat of fusion. Okay, but this one is talking about what? Latent heat of vaporization. So that's the okay, that's a mistake. So in this case, so the energy we are looking for, that is Q, will be equals to 0.54, okay, multiplied by the latent heat of vaporization, which is 2300. Remember, the unit of this will be what? Joules. Okay, it will be joules. Why? Because the unit of this is a kilogram. Okay, we have this is kilogram multiplied by 2300 kilojoules per kilogram. So kilogram, we cancel kilogram. So that this will be Q equals to, remember, we have kilojoules. So this will be equals to 0.54 multiplied by 2300. That will be 1242. So this will be 1242 kilojoules. And this is the heat required to change 30 moles of the liquid to gas. The noblest pleasure is the joy of understanding. Bye bye.